Welcome to inverse trig derivatives. Right? So when you're notating inverse trigs, you can either use the inverse notation, right, the F inverse, or with the prefix arc. Right? So you can write it as sine with the inverse notation, that -1 there, or you can say arc sine. Right? Either of those is perfectly acceptable, and that goes for all of the different trig functions. All right, so here are our inverse trig derivatives. You saw how they were derived in the last Nearpod. All right, so the derivative of arc sine is, so now if x is just, if we're taking the arc sine of just x, right, then we would have a 1 in the numerator. So the numerator is going to be the derivative of whatever we're taking the arc sine of, right? So whatever's in that parentheses, whatever that function is, right? So we're going to have to take because this will be a chain rule, right? So the derivative of the outside, we have the derivative for arc sine, derivative times the derivative of the inside, we have the derivative for that function that we're taking the arc sine or the arc cos or the arc etc. of. All right, so arc sine is f prime of x over the square root of 1 minus f of x squared. If that's an x, then that's an x squared. If that's something else, it's whatever that something else is squared. And we're going to see that as we look at doing some problems together. Arc cos is basically the same derivative except for the sign. So it's going to be negative f prime of x over the square root of 1 minus f of x all squared. Arc secant, right, is going to be f prime of x over, divided by, the absolute value of f of x times the square root of f of x all squared minus 1. Arc secant is going to be the same thing, except it's negative. Right? So, excuse me, arc cosecant. Arc cosecant is going to be the same thing, except it's negative. So we're going to have negative f prime of x over the absolute value of f of x times the square root of f of x all squared minus 1. And then finally, arctan is f prime of x over 1 plus x squared. And actually, that should be f of x squared, excuse me. Didn't catch that one. Plus negative f prime of x over 1 plus f of x squared. All right, so arc cotangent is basically the same thing as arctangent, except for the sign. All right, so those are our 6 inverse trig derivatives, and we're going to use these formulas. You saw how they were derived. We don't have to derive them again, so that we can take the derivatives of some inverse trig functions. All right, so we want to find, it says take the derivative of arc secant of 3x. All right, so we're going to, in the numerator, we'll go the derivative of 3x. So that's a pretty easy one. And actually, I'm going to write I was going to write the formula. I think we'll be, there's only so much space on this page. Maybe I'll write it up here. All right, so this is going to be f prime of x will be, arc sine of x is going to be f prime of x over the square root of 1 minus f of x squared. All right, and so we have to take the derivative here of that 3x. So that's our f prime of x. The derivative of 3x, of course, is 3. All right, so this is going to be, all right, so our derivative here is, and I'm going to just put dy dx. Dy dx equals, so in the numerator we'll have a 3. In the denominator we have a square root of 1 minus 3x all squared. That's our f of x. All right, so now we just simplify that. So dy dx equals 3 over the square root of 1 minus 9x squared. Right? And 1 is done. That's a little reminder of, since I have this base up here, and it's doing nothing, of arctan. And the problem should be in your notes. You don't have to write the formulas again. I'm just doing that on this page. All right, and so it's going to be f prime of x over 1 plus f of x squared. Seems to have the wrong number of parentheses there. There we go. All right, so we do have not just an x, right? We have a 2x squared. All right, so that's going to be f prime of x. That derivative of that inside part, as we do the chain rule here, of 2x squared is going to be 4x. So the derivative, dy dx, will be 4x in the numerator, right? The derivative of what we're taking the arctan of, over 1 plus 2x squared, all squared. So we'll simplify that out. Dy dx equals 4x over 1 plus 4x to the 4th. And we're all done. Another one done. All right, let's look at the third one. All right, so arcsecant. All right, so that one, we're going to have f prime of x. And then that one has the absolute value of f of x times the square root of f of x squared minus 1. It's kind of like the others, but it's kind of like the arc sine and the arc cos, but they're reversed. That's the way you can think of it. All right, and so we have we want to take the derivative of arcsecant of 5x to the 6th. All right, so for our chain rule, let's figure out the derivative of 5x to the 6th. All right, so that's going to be 30x to the 5th. So the derivative, dy dx, is equal to 30x to the 5th, the absolute value of 5x to the 6th, times the square root of 5x to the 6th squared minus 1. Now, you could probably reduce that 30x to the 5th and 15x to the absolute value of 5x to the 6th, right? But I just tend to leave it like that. I don't really worry about it. But if it's reduced, so you don't have to worry about reducing it. This is fine. But we're going to simplify that square. But if you happen to see it on a test and you don't see this answer, you see a reduced answer, well, that must be your answer. I just find it easy. Then I don't have to worry about, did I reduce that right because I got these absolute value bars? Do I still need them? And then it's easy to see what the the relationship between the function and its derivative like this. All right, so we have the absolute value of 5x to the 6th, and the square root is 25x to the 12th minus 1. And there we go. All right, so now here's the challenge question. So it won't be it'll be a little while, but in a while, a good while, we're going to be going back the other way. All right, meaning that I'm going to give you the derivative, and I'm going to say, whose function is this? All right, so here we're going to just use a little logical thinking and trial and error, and in the future you'll have some more strategies to use. All right, so I see that the format here, I've got a square root of 1 minus a perfect square. Well, it's one of these three who is always set up as 1 minus a perfect square root of 1 minus a perfect square. Right? It's got to be either arccos or arcsec, right? Arccosine or arc. Let's try that again. Arcsine or arccosine. But it's positive, right? So that means it's not going to be arccosine. It's going to be arcsine. Right? So now if we think of the formula here, arc sine of x, we have f prime of x over the square root of 1 minus f of x all squared. Well, let's take the square root of that 36x to the fourth because we had a function squared. All right, so the square root of 36x to the fourth is going to be 6x squared. Now, in the numerator is the derivative of f of x. So if this is f of x, what's f prime of x? Well, that would be 12x. And look, that matches what we have, right? So the derivative of 6x squared, that's our 12x. And 6x squared, that's our 36x to the fourth. So what is the antiderivative? In other words, what function has that derivative? The function is f of x equals, we have arc sine, and in the parentheses is going to be 6x squared. So that's what function has that as a derivative. And we could go the other way to check it out. All right, so if we took so this is our answer. Answer. Here we'll check. Oops, my eraser's in the wrong drawer. There we go. I'm going to switch colors. Here's the check. All right, so we're going to take the derivative. All right, so we know the derivative of 6x squared, we already figured that out, is 12x. So this is going to be dy dx equals 12x over the square root, and we know our format, 1 minus 6x squared. And 6x squared is 36x to the fourth. So, yep, that checks out just perfectly. Let's do a few more. Okay, for a second it looked like the same problem, but it was a sign, but it was like a 3x, I think. All right, so we want to take the derivative of arc sine of 5x. All right, I'll write the formulas just so that we have them. All right, and so arc sine, that derivative is going to be, and I really should probably write the derivative of arc sine, getting sloppy here, would be f prime of x over the square root. You'll have these memorized, but me keep saying them, of f of x squared. All right, so we need to, as part of the chain rule, we need to take the derivative of 5x, and of course that's going to be 5. So dy dx equals 5 divided by the square root of 1 minus 5x squared. And so 5x squared, that's just 25x squared. Right? So this is going to be 5 over the square root of 1 minus 25x squared. Right? That's not too bad. All right, so our cosecant is just like secant except for the sign. So this is the derivative of our cosecant is f prime of x over the absolute value of f of x times the square root, negative, don't forget the negative, and then f of x squared minus 1. All right, so we need to take, as part of the chain rule, we need to take the derivative of the 4x to the fifth. Right? That's going to be equal to 20x to the fourth. So dy dx equals 20x to the fourth over, nice straight line there, absolute value of 4x to the fifth times the square root of 4, man, I don't have enough space here. Let me write a little smaller. Maybe if my line was a little straighter, huh? I'm going to run out of space to simplify. Yeah, let's try that. Let's see if we can cram that up a little bit. I think that's all right. All right. Absolute value of 4x to the fifth times the square root of 4x to the fifth squared minus 1. So dy dx equals 20x to the 4th divided by the absolute value of 4x to the 5th, and that is times the square root of 16x to the 10th minus 1. Right? If you're squaring and if you're raising a power to a power, just multiply the exponents. All right. I think arctan is just the easiest. So the derivative of arctan is going to be f prime of x over, oops, can't write there, over 1 plus f of x squared. All right, and so we need to take the derivative of 2x. That's going to be 2. So dy dx equals 2 divided by 1 plus 2x all squared. Could that be any easier? Dy dx equals 2 over 1 plus 4x squared. Done. All right, so now we're taking the arc sine of sine. We're taking the derivative, I should say. We're taking the derivative of the arc sine of sine. All right, so let's see. What's the derivative of sine? All right, that's equal to cosine, right? All right, so we have dy dx equals the derivative of sine x would be cosine x divided by the square root of 1 minus sine x squared. Oops. Sine squared x. There we go. Which is sine x all squared. All right, that's just how we write it, right, for sine and cosine and all of our trig functions. You know, gee, that 1 minus sine squared x, that looks really familiar. Like I've seen some formula before that maybe looked like that. Let me think. So sine squared x plus cosine squared x equals 1. That means that cosine squared x minus, cosine squared x equals 1 minus sine squared x. Well, how about that? I could replace 1 minus sine squared x with cosine squared x. How about that? Let's do that. All right, so dy dx equals cosine x over the square root of cosine squared x. Well, cosine squared x is a perfect square. I could take the square root of cosine squared x. That's cosine x. So dy dx equals cosine x over cosine x, which is 1. Isn't that crazy? Oops, I just hit the chair. Isn't that crazy? We got a derivative of 1. Well, remember that, let me see, I can squeeze that in here. Sine and arcsine, I should have an x in there. So sine x and arcsine x are inverses. They undo one another. And when we have a composition of inverses, what's left is x. So without the derivative, just this, the arcsine of sine x equals x. And the derivative of x is 1. Right? So we could have simplified first, but I really wanted to practice this and go over this because you could definitely find the derivative. But you should look at that and go and see if you can simplify that. 1 minus sine squared x, that's cosine squared x. Oh wait, the square root of cosine squared x, that's cosine x. Oh wait, it's just 1. All right, so that's a fun little one there. So that was one you should definitely simplify. All right, and do I have room for the formula for, well, the formula for arc secant is the same as arc cosecant. Just take out the negative. Equals f I got to drink water. F prime of x over the absolute value of f of x times the square root of 1 minus, excuse me, the square root of f of x all squared minus 1. All right, so we have to take the derivative of the inside function. That's derivative of x cubed, which is 3x squared. All right, so this is going to be dy dx equals 3x squared over the square root. Do you know what I forgot? So after I finish this, let's go back up to number 2. After I wrote the formula, I forgot something. Let's see if you figure out what I forgot. So 3x squared over the absolute value of x cubed times the square root of x cubed squared minus 1. Right, so that's going to be dy dx equals 3x squared over the absolute value of x cubed times the square root of x to the 6th minus 1. So guess what I forgot in number 2? Big gold negative. There we go. I even wrote the formula down. All right, arc cos. All right, so arc cos is just like arc sine, except for the sine. So the derivative of arc cos is going to be f prime of x over the square root of negative f prime of x over the square root of 1 minus f of x squared. I'm having an issue with negatives today. All right, so we have to take the derivative of the inside. So the derivative, again, of sine x is going to be cosine x. All right, so we have dy dx equals cosine x over the square root of 1 minus sine squared x. Now, let me think for a moment. 1 minus sine squared x. I think we've seen that one before. All right? Oh, excuse me. Negative cosine x. What is it with the negatives? Negative cosine x over this absolute value, over the square root of 1 minus sine squared x. Let's simplify that. dy dx equals negative cosine x divided by the square root of, we can replace that with cosine squared x. dy dx is negative cosine x over cosine x. So our answer here is negative 1. So if we remember, sine x and cosine x are the same, or basically the same function, but shifted. Right? It's like taking that function and shifting it. And that's, when we shift it pi halves, we get, shift sine pi halves, you get cosine. Shift cosine pi halves, you get sine. So that shouldn't be surprising, I guess, that when we took the derivative of arc cos of sine, they canceled each other out, and we get negative 1 this time. And getting close to where I want to take, yeah, let's make this 2 videos. Let's stop right here. All right, I'm going to pick up in the next video with these problems. All right, thanks for watching. Bye for now.